Solutions for the final exam, third 9 weeks. A chemical reaction occurs between 1.6157 times 10 to the 23rd molecules of solid ammonium phosphate and a 2.6 molar solution of calcium nitrate. Okay, so the first things first is I need to write a balanced chemical equation. Okay, so I can already see here, let's see, so this is ammonium phosphate is going to combine with calcium nitrate. Sorry, let me see here. Gonna just quickly adjust this. I don't think I optimized. There we go. Sorry about that. That's why I was kind of hesitating here. Okay, and that's going to produce calcium phosphate. Okay, plus ammonium nitrate. Now, how did I know that these were going to be the products? Well, first and foremost, I have here two compounds, which tells me that this is going to be a double replacement reaction. In a double replacement reaction, what happens is the two positive ions, right? These guys just switch places. So for the products, right, ammonium then is going to bond to nitrate, and calcium then is going to bond to phosphate. Now, how did I get these compounds? Well, if I look over here, calcium, for example, I'll do one. Calcium carries a 2+ charge, okay? And phosphate carries with it a 3- charge, okay? Bring this number over here, bring this number over here. We've done this 100 times, and your compound is calcium 3PO4 2. Okay, this is not anything new. So you guys should know how to do this by now. Remember that the subscripts and the reactants do not carry over to the products. Okay, you have to do this process here all over again. Just like you did in the reactants, you have to do it in the products. Okay, so let's go ahead and balance this. Let's see, I have ammonium. I have phosphate. I have calcium. And I have nitrate. Okay, so here I have, I'm going to erase this in a minute because I need the space. Okay, so I have 3 here. I have 1 here. Phosphates, I have 1 phosphate here, and I have 2 over here. Calcium, I have 1. I have 3. And then nitrates, I have 2, and I have 1. All right, so looking at this, let's start with the one that has the least amount. We can either start with phosphate or we can start with nitrate. So I'm gonna go ahead and start with phosphate. In this case, I have 3 phosphates, or 2 in 1, but I have a total of 3 because there's 2 in 1, 2 here, 1 here. So that's the least amount of molecules that are unbalanced. So I'm gonna start with phosphates. Okay. So first things first, I'm going to go ahead and I'm going to add a coefficient of 2 right here. Okay, by adding a coefficient of 2, then that changes this to a 6. That changes this to a 2. So now that's balanced. Okay, since I affected the nitrates, I'm going to jump over to the other side of the nitrates here. Okay, and I'm going to see if I can balance that. Okay, so if I have 6 here, then I'm going to add a 6 here. That's going to change that. Okay. And then that's going to also affect my nitrates. Okay. All right. Since I'm doing the nitrates now, I'm going to jump across the way here to do the nitrates. I have 2 nitrates here. So to get that to a 6, I just need to put a 3 right here. And that becomes a 6. Okay. 6, 6, 2, 2. Calcium. What about calcium? Oh, that affects calcium too, right? So sometimes by bringing something into balance, you also bring something else into balance along with it. This is your balanced chemical equation. Before you do anything else, you need to have a balanced chemical equation so you can start the problem. Okay. All right. I'm going to erase this here. Feel free to pause or rewind so you can see what I'm doing. And then, you can advance the video. All right, now that we have a balanced chemical equation, now we got that taken care of, now we can start working the problem. So it says here that I have 1.6157. Okay, so I know that in order for me to calculate product, I'm going to have to use stoichiometry. If I'm going to use stoichiometry, I'm going to use mole ratio, and I can't use mole ratio without moles. So I need to convert my values that I have into moles. 6.157, a little bit too thin, times 10 to the 23 over 1. Okay, I know that for every, oh, sorry. This is molecules. See, I almost did the cardinal sin of not writing units of, let's see, what is this? Ammonium nitrate. So I'm going to just abbreviate NH4. No, might as well. Okay. So I know that 1 mole of ammonium nitrate, sorry, ammonium phosphate, okay, is 6.022 times 10 to the 23rd molecules of ammonium phosphate. Okay. Remember that when you're converting, anytime you see molecules, you have to use Avogadro's number. All right. So I'm going to go ahead and punch this into my calculator. I want to do this full time with you guys. I'm sorry, real time. So we can see how to work through it. Next one. I don't want to have anything already set up. Divided by 6.022 exponent to the 23. Okay. So that's going to give me 0.2683 moles of ammonium phosphate. Okay, so if you got something close to that, if you only use 3 decimal places, that's okay. That's going to be a small rounding error, so not to worry. Okay, next thing I need to convert into moles is my calcium nitrate. So I have a solution, right? Solution that is 2.6 molar, okay, at 130 mLs, 130 milliliters. Okay, so in order for me to convert this to moles, I know I'm going to need the molarity formula. So that's going to be molarity is equal to the moles of a solute over the volume or the liters of a solvent, right? I know what I have. I know my molarity is 2.6 molar, and I know my volume is 130 mLs, or if I want to convert that to liters, it's going to be 1.30 liters. And my moles is what I'm looking for. That's my unknown. So I have to solve for moles, okay? Molarity is equal to moles over liters. If I want to solve for moles, I'm going to multiply both sides by the volume. This cancels here. So moles is equal to the volume times the molarity. Once I have my algebraic manipulation done, all I have to do is plug everything in. So my volume is going to be 0.130 liters. Okay, and my molarity is going to be 2.6. The units, the expanded unit for molarity is moles over liters, right? Because that's what it says here, moles over liters. These two guys multiply, liters cancel. So let's take a look here. Punching into my calculator, 0.130 times 2.6. And that should give you a total of 0.338 moles of calcium nitrate. Okay. I'm going to box in my answer. Okay, let me go ahead and box in this one too, just so we know. Okay, so now I've converted all of my things to moles, right? So if I have moles, then now I can start doing stoichiometry. Okay, all right. So I'm going to do this in yet a different color. Okay, so now begins my stoich. Here I have to find my limiting reactant. I cannot calculate the amount of product if I don't know which one is going to run out first. Remember that the limiting reactant is going to dictate how much product is formed. So I'm going to just pick one. I'm going to just pick calcium nitrate. So 0.338 moles of calcium nitrate. Okay. I'm going to multiply that by the mole ratio. Okay. The mole ratio is going to be the ratio of the two reactants. In this case, it's going to be 2 moles of ammonium phosphate. Okay, over 3 moles of calcium nitrate. Now, remember, guys, that you have to set these up in a way so that the same unit cancels out, right? So when you set your mole ratio, you need to set it up so whatever unit is here matches the one at the bottom here, so you have a cancellation. So you have a unit conversion. So 0.338, I'm going to multiply everything across the top, times 2 is equal to 0.676 moles of ammonium phosphate, okay, over or divided by 3. That's going to give me a total of 0.225 225 moles of ammonium phosphate, sorry. Okay, so this here is the amount of ammonium phosphate that I'm going to need for this reaction. Okay, now if you look here, this is how much ammonium phosphate you actually have. Okay, so the amount you got from the question that you converted to moles, that's what you actually have. So in this case, I have 0.2683 moles of ammonium phosphate. Okay, so this is the amount that I have. You always calculate the need, and then the given is going to be your have. In this case, I can see that my have is going to be bigger. Okay, so what that tells me is that my have is more than my need, right? So I have more than I need. Because that's the situation, okay? Here's what I can determine from here. That means that ammonium phosphate is going to be my excess. Okay, and if ammonium phosphate is my excess, that means that calcium nitrate is going to be my limiting. Okay, that's going to be my limiting. All right, so now we can begin to calculate how much of the solid is going to form. But how do you determine which one is solid? Okay, this is where the solubility chart comes into play. Okay, your solubility chart is going to be how you determine whether something is going to stay in solution or whether something is going to stay in or going to become a solid. So you got to check both of these, okay? So the first one is calcium phosphate. So first thing I got to do is I got to find calcium. So there's calcium right there. There's phosphate right here. And if I go all the way across, right, and I come all the way down, this guy tells me that calcium phosphate is insoluble. So for this, in this reaction, this is going to be my solid. So then you put an S there, right? But you got to check both. You got to check both, right? So let's go back and let's take a look at ammonium phosphate. So here's ammonium right here, okay? Ammonium nitrate, sorry. And then nitrate is here. So going across here and then coming all the way down here, I can see that this guy is going to be soluble. So ammonium nitrate is not going to form a solid. That's going to remain in solution. So I'm going to write an AQ here for aqueous. Okay, aqueous means that it's going to be in a water environment, but it's going to stay in a solution. So using your solubility chart, now I know I need to find calcium nitrate, right? Or calcium phosphate, sorry. So solid is equal to calcium phosphate. Okay. Now, how do I calculate this? Okay. How do I determine how much of this was produced? Well, stoichiometry is the magic word here, guys. Okay. So in order to do this calculation, I need to use a mole ratio. So I'm going to come back up here and I'm going to say, okay, I figured out that this guy is my excess and this guy is my limiting. So I'm going to take the mole ratio from the limiting reactant, right? I'm going to see if I can highlight this, my limiting reactant, okay, to whichever product I want to calculate. In this case, I want to calculate calcium phosphate. So I'm going to take the mole ratio from calcium nitrate to calcium phosphate, okay? The stoichiometry is what helps me determine how much of a product is formed. So the mole ratio then is going to be the mole ratio from the desired product, okay? And the product can be anyone, it doesn't have to be the solid. And just in this case, that's what I'm looking for. So from the desired product to the limiting reactant, okay? So that mole ratio is going to be 3 moles of calcium nitrate. And for every 3 moles of calcium nitrate that is used or consumed, 1 mole of calcium phosphate forms. Okay, and that's the mole ratio. All right, using that mole ratio, we're going to be able to calculate how much is formed. So how much calcium nitrate do I have? So let's take a look. We've already calculated that, right? We have this many moles of calcium nitrate. Okay, right here. We calculated that because we used the molarity formula. Okay, so I'm going to start with that. I'm not going to start with my calculation. I'm not going to start with my theoretical because I need to know how much I'm working with. So I have 0.338 moles of calcium nitrate. Okay, I'm going to put that over 1. Then I'm going to multiply by the mole ratio. I'm going to multiply by the mole ratio, which is in this case, 1 mole, right? Oh, I flipped these, by the way. Sorry. 1 mole of calcium phosphate over 3 moles of calcium nitrate. It's supposed to be over the limiting. I just flipped them right here. Okay. The reason I had to flip it was because I needed to cancel these. Okay. So 0.338 times 1 is 0.338, obviously. And then I'm going to divide that by 3, 0.338 moles of calcium phosphate divided by 3. So I'm going to take that divided by 3. That's going to get me to 0.11267 moles of calcium phosphate. Now, me personally, I don't like to round until the very end because that makes my answers that much more accurate. Okay, so I'm going to keep working with these numbers and then I'll round it at the end. Okay, so now I have how much of this product, how much of this solid should be produced. Okay, the problem is that this is in moles and I need it in grams. So if I'm going to convert to grams, okay, remember, anytime you see grams, there should be a red flag that goes up that says you need either molar mass or atomic mass. Okay, so because this is a compound, I'm going to find the molar mass of this guy. All right, so I'm going to screw this up a little bit. All right, so I have in this compound, I have calcium, I have phosphorus, and I have oxygen. Okay, so let's go ahead and start solving this. So calcium is 40.078. There's 3 calcium, so 3 times 40.078. In this compound, there are 2 phosphorus. So that's going to be 2 times 30.9737. Remember, I told you guys I'm doing this in real time with you. Okay. And then there's 8 oxygens, which is 8 times 15.999. Okay, get these guys all multiplied out. So 3 times 40.078, that's going to give me 120.234. 2 times 30.9737, that's going to give me 61.9474. Okay, and then 15.999 times 8, that gives me 127.234. 0.992. Okay. All right. I'm going to add all these guys up. So let's see that plus 61.974 plus, let's see, whoops. Okay. That gives me a total molar mass of 310.173 grams per 1 mole. Or I can say that 1 mole of calcium phosphate is equal to 310.173 grams. Okay, so how do we use the molar mass? Okay, so unit conversion is very simple. You have your given unit, which is here, their given amount. Okay, and this is your conversion factor. Remember, this molar mass is a conversion factor. Okay, so you got to figure out which one goes on bottom. Well, since I have moles here, I'm going to add 1 mole to the bottom to make sure that they cancel. Now I'm writing all my units and you guys should be writing units too. Remember that you lose 1 point for every missing unit. So I hope you guys wrote all your units. Okay, so there's that. I'm going to multiply everything across the top, everything across the bottom, divide at the end, 0.112667, enter, and I should end up somewhere in the realm of 34.9463 grams of calcium phosphate. Okay, so this is your answer. Now, if you want to round this, I'll accept a round. So this would be, you can do up to 34.95. You want to have at least 2 decimal places, right? All right, so if you're within this ballpark, then you should get full credit, okay? If you have slight differences, this is going to be for rounding, so it is what it is, but that's why I like to round at the end, okay? This is how you calculate how much of the product was formed, okay? So this is the solution for question 1A, okay? All right, let's go back up to the question here. Well, all of this is a solution for question 1A. All right. All right, it says here, how much material will remain unreacted in this solution? Okay, so this goes down to a very basic principle, guys. We didn't do a specific one like this in class because you guys need to be able to figure this out and you got to think, okay? You have 2 types of reactants. You have a limiting reactant and you have an excess reactant, okay? One of those is going to be consumed first and one of those is going to have unreacted material, right? Which one do you think is going to have the unreacted material? Well, in this case, it's going to be the excess, right? So this guy is going to have leftovers. And this I did tell you. What question 1B is asking you is how much of what you have is going to be left over, right? So let's take a look here. It tells you right here, look, we calculated this way. So I can see how much I need of ammonium phosphate because this is my excess, right? And how much I have of it. So if I need 0.225 and I have 0.2683, how much of that is going to be unreacted? Well, that's pretty easy because all I have to do then is take the have minus the need. Okay, so I have 0.2683, right, minus 0.225. So let's see how much is going to remain unreacted. So 0.2683 minus 0.225. So this question wasn't a lot of work, but this question was one of those that kind of makes you think, okay? The idea behind it was you got to try and figure out, you know, how to get that. And it's one of those, you just got to use your brain a little bit, right? So basically what we're saying here is that 0.0433 moles of NH4PO4 will remain unreacted. Okay, I wanted that one in grams. So basically all you have to do, and I'm not going to do another one just because we've already done one, is you're going to convert this to grams using molar mass. Okay, using molar mass, you convert that amount to grams. All right. Now, if you did it the other way, where you calculated the need and a half of the calcium nitrate, then you would have to go back and do this calculation here, okay, to calculate the need and a half of the ammonium phosphate. But in this case, it just happened to work out that I already had the need and a half. So it was good. It worked out pretty good for me. That was unintentional. I didn't plan that ahead. It just kind of worked out that way. Okay, so it says here, if I want to dilute calcium nitrate solution from 1 molar to 1 molar, how would it be done? Explain your writing in complete sentences. Okay, so I'm going to talk in complete sentences, but I'm not going to do it on the, I'm not going to sit here and write everything out because I don't want to waste you guys' time. Okay, so for 1C, it's a dilution. Okay, so if I know I'm going to dilute something, I know I need to use the formula M1V1 is equal to M2V2. Okay, so I know that my starting solution, okay, so my M1 is equal to 2.6 molar because that's given to me in the question. The original volume of the solution was 130 mLs. This one you do not have to convert to liters. You can leave it the way it is. And I want to dilute this to 1, was it 1 molar? Let me double check. Yes, 1 molar. Okay, sorry about that. So I want to dilute this to 1 molar. Okay, and I got to figure out, well, what's that going to be, right? This is my unknown, so I'm going to put that as X. All right. So I have all these values, and I have to figure out what my final volume is going to be. And I'll explain to you guys why I know it's the final volume. Okay. So I need to solve for V2. So M1V1 is equal to M2V2. And I got to solve for V2. So in order to solve for V2, I got to get M2 and bring it over here. Now, M2 and V2 are multiplying, right? We understand that's a multiplication. So to move something to the other side of the equal sign, I have to do the opposite operation. So that means I'm going to divide by M2, right? If I do it to one side of the equal sign, I have to do it to the other. So these guys cancel. And to solve for V2, I'm going to take my M1 times my V1, and I'm going to divide all that by my M2. So what does that look like? Now that I have my formula, all I have to do then is plug everything in. My M1 is 2.6 molar. Okay. My V1 is 130 mLs. Okay. And then my final molarity, or my final concentration, is 1.0 molar. Okay. When I do this, my molarity concentrations cancel. Okay. So I'm going to take 2.6 and I'm going to divide that by, 2.6, I'm going to multiply that by 130. So that gives me 338 milliliters divided by 1. So V2 is 100 or 338 milliliters. Okay. Now, I figured that out. What does that mean? Okay. So all this stuff actually means something. All right. It's not just random numbers up here. So if I have a vessel, right, and this is what you would write, right, in complete sentences. So to dilute this solution, right, I have 130 mLs, right, 130. I don't know why it does that, but it is what it is. So we have 130 mLs, okay, of the original solution. Well, I don't know what it's doing here. At 2 molar, okay, 2.6, sorry, let me erase that. Oh. Okay. So what this is telling me then is I need to change the volume from 130 to 338. So how much water, in this case, that's the base, right? How much, or solvent, how much water do I need to add? okay? So I got to change the volume from 130 to 338. Therefore, 338 minus 130 is going to give me 208. And I did do it in my head, but I want to double check. Equals 208. So to get the final volume to 338 milliliters, I'm going to take 130 milliliter solution, okay? And to this solution, I'm going to add 208 milliliters of water or solvent, okay? And by doing so, that changes my concentration from a 2.6 molar concentration to a 1 molar concentration, okay? So to make this dilution, I'm gonna take the 130 milliliters that I have, and to that solution, I'm gonna add 208 milliliters of solvent. When I reach a total final volume of 338 milliliters, then my concentration is going to change from 2.6 to 1.0, okay? So that's it, guys. That's the solution for the test. If you have any questions, please let me know.